Dev logic. Not so everyday logic for everyone.
Good day, guys. Today we will be looking at linear regression as one of our machine learning algorithms. In our last video, we looked at logistic regression and using logistic regression to predict whether a breast cancer is malignant or benign. And today we'll be using linear regression to predict the price of a car using some data points. Sorry about this. Okay, so now let's delve right into the code. Oh no, let's look at the data set first. This is our data set. Our data set consists of the price, the age, like how old the car is, the mileage, the fuel type, the horsepower, whether the car is automatic or not, the number of doors, and the weight of the car. Now, if we look at this data, this is a lot of numeric data, but we have some categorical data here: diesel, petrol, and CNG. And if we go to our linear regression to pi, I'll explain to you how we actually work with that later on. Now, first of all, we import the random to help us generate random values later on for testing. We import pandas to help us reading our CSV file and to help us working with the data. We import numpy to help us with numerical things that we need to do. We import sklearn, which is our scikit package, and we import the matplot library to help us plot and visualize our features at the end of the day. Now, first of all, we need to actually fetch our data, and we have this get data function, which basically helps us get the data from this location. And we have our pandas that read CSV, which helps us, get the data from this particular location. And since it's a comma separated file, you use the commas to actually represent the thing being delimited by commas and to give us each feature one by one. And since our features, if you look at our data set, the first column, the first column is the labels, and so we just take that out since that represents our labels, and the rest of them would represent our features, and we return our features and our labels. The next thing we need to do is that we need to pre-process our data, right? And to pre-process our data, like I told you earlier on, we had some categorical data, the diesel, petrol, and CNG. And to actually work with that, we needed to actually convert them to what we can actually work with. And so what we did is that we encoded it. Now, what encoding is basically, like I said earlier on, converting it to values that can be worked with. So diesel will probably represent 1, petrol represent 2, and CNG represent 3. So anywhere we see diesel, replace it with 1. Anywhere we see petrol, replace it with 2. And anywhere you see CNG, replace it with 3, which is what we're trying to do here. And we saved it in the position it was supposed to be. Now, the next thing is that we need to actually split our data into training, validation, and testing data as usual. And since we have about 1,436 features, we basically use 500 for training, 500 for testing, and about the remaining 500 for training, 500 for validation, and the remaining for our testing. And so we return these values to actually work with them and give us what we need. And the next thing we want to look at is our linear regression function. Now, with the linear regression, we're using the linear regression provided to us by scikit-learn, and so we just call it. And if you observe, during our pre-processing, we didn't normalize the values. Why? Because we could actually normalize them here, which is exactly what we did. And the next thing we need to do is to actually now fit our model using our training data, and we fit it over here. And then the next thing after fitting the model is now we want to actually validate the model to see how the model is performing using the validation data. And we call the model.predict and pass on the validation data over there. And then we print out the coefficients, we print out the mean squared error, and we print out the variance score. Like it said over here, the 1 is for the perfect prediction for a variance score, and we'll see how our model is going to do later on. The next thing that we also want to do is to visualize the results of a test. So see how the true prices were compared to the predicted prices in the form of a scatter plot. There are different ways to visualize your data and to visualize your results, but I just chose to use a scatter plot. It's just preference. And afterwards, so we actually use the horsepower as compared to the price, and then we title it and we save it over here. and we return our model for further testing and for further work. And now over here we have our test model, and what we do right here is we pick a random value from 1 to 435, and then we now predict our model using the testing data, and we have our set of results. And now we just pick a random value to actually show how that particular random value behaved with the model, and we just verbosely like let you know what the age of the car is, what the mileage of the car is, the horsepower, whether it's automatic or not, the number of doors, and the weight of a car. And the next thing we do now is that we just let you know how much the model predicted the car to cost and what the car actually cost, which is what's going on here. And over here now we actually call our functions, right? We call our label, we return our labels and our features, then return our training data, our testing data, our validation data, and then we return our linear model when we call the linear regression, and we return our test model when we call the test model function, which actually gives us how the model is working. And now if we come over here, we actually want to run this to see how it actually works. And when we hit the enter button, we're gonna wait for a couple of seconds for it to actually work, and that should be soon. Okay, here we go. Okay, right now this is a result, and we can see over here it gives us our coefficients right here, and it lets us know our mean squared error and our variance score. Now, like I said, the perfect variance score is actually 1, but our model obviously isn't spectacular, which is why we are having a variance score of negative 0.47. And these are our chosen samples, and we have an age, the mileage, the horsepower, the automatic, whether it's automatic or not, the number of doors, the weight of the car. And it lets us know that for this sample, our model predicted the car to cost $7,883.18, but the car actually cost $7,900, which is kind of close to it. But like I said, our model isn't spectacular, as we can see from the variance score. We can actually see that it's really not so good. But for the most part, we're just looking at how to actually perform linear regression. You can actually do other things or use less features, or do more processing of your data set to actually give you better results, and you can look at that later. But for now, we just wanted to look at simple linear regression. And so these are the results. We see what the car was predicted to cost and what the car truly cost. And now we would also visualize our results. So if you come over here, you can actually see a scatter plot of the predicted results and the features, and the triangle represents the true price and the stars represent the predicted price. And so these are basically just showing you how, like the horsepower compared to the price, saying how it's actually predict like what the results are. And I think that's about it. We looked at simple linear regression, getting our data out, and we looked at the results as to how to pre-process our data, normalizing the data, looked at the variance score, the mean squared error, the coefficients. We visualized the results, and we used some test value to actually see how our model worked in the real world. Anyways, that's about it for now. Thank you very much for listening, and thank you for your time. Have a good one.